On most modern gas furnaces, the high limit switch is a little click-on switch that is mounted on the furnace firewall and extends into the cells of the heat exchanger to protect the furnace from any overheating condition. One of the most common calls that tech support gets during the winter is the furnace high limit switch keeps tripping, and the technician reports either a code 33, which is high limit switch trip, or a code 126, which is high heat alert, which means the furnace has tripped on the high limit switch more than 2 times. The conclusion that the technician usually comes to is that it must be the furnace, but not necessarily. Let's check a few things first. The first thing that we want to check is the incoming gas pressure from the gas meter. You do this by taking a gas pressure reading on the meter side of the gas valve at the furnace. You want to make sure that you have at least 8 to 10 inches of water column supplied to the gas valve on the furnace. If you do not have this, then you will need to get the gas company to adjust the gas meter to give you that pressure at the gas valve. The next thing we want to do is check the manifold side pressure. Check manufacturer specs for proper manifold gas pressure settings. If you are working on a modulating gas furnace and all checks have been made and the high limit still trips, you may want to consider resetting the modulating gas valve. The procedure for doing that is available from tech support. When checking the gas manifold pressure on a gas furnace, if you're working on a furnace that has numerous ignition problems, you might want to check the manifold pressure along with all the other gas appliances in the home. It's possible that when the gas furnace is operating, that when other appliances come online, that they will drop the manifold pressure to the point where it can no longer support flame. By running all of the appliances together, you can see if the manifold pressure of the gas furnace maintains flame while the other appliances are operating. Once we have the gas supply and manifold pressure set correctly, then we want to take a temperature rise through the furnace. To do this, we need to take the return air temperature and the supply air temperature away from the radiant heat of the heat exchanger. We then take these two numbers and subtract them to get our temperature rise through the furnace. We then want to compare this temperature with the data tag of the furnace to see if we are within range for the temperature rise for this particular furnace. If our airflow as far as temp rise is concerned is in line, then we want to look for smooth airflow with very little turbulence and no recirculation into the furnace. This bullhead connection is a typical connection on a lot of furnaces, and it provides for pretty good recirculation back into the furnace as the air hits the top of the connection and then bounces back into the furnace, tripping the high limit. It also has a very high equivalent length of 120 feet. This can be reduced quite dramatically with vanes or transitions to give smoother airflow out of the furnace. The bullhead fitting with directional air coming out both sides of the fitting is also a good candidate for recirculation back into the furnace and also has a very high equivalent length. It can be reduced by putting turning vanes, which directs the air out of the furnace and reduces the equivalent length and recirculation of this particular type of fitting. The same holds true with a fitting like this on a downflow application where the air exits the bottom of the furnace, hits the bottom of the plenum, and then recirculates back into the furnace. This also has a very high equivalent length of 120 feet. This can be resolved by either giving more length from the bottom of the furnace to the bottom of the plenum, or by putting turning vanes, which will direct the air out of the furnace and will reduce the equivalent length of this fitting. Another thing that you want to check with an AC coil on a gas furnace is if the flat portion of a coil is directly under the high limit switch, you may want to construct a sheet metal triangle to direct the air around that area for smoother airflow and prevent recirculation back on the high limit switch. Let's recap what we have learned. First, check the high limit switch for proper operation. There is a 1 in 100% chance that the high limit switch is tripping at a lower temperature than it should. So always check the high limit switch for proper operation. Next, check the gas pressure, both supply and manifold. Run all gas appliances to make sure the manifold pressure is maintained when the other appliances are operating. Check the temperature rise and compare to the data tag on the furnace. Check for smooth airflow with no turbulence or recirculation. Make sure your fittings provide smooth airflow out of the furnace. And make sure the AC coil is not causing turbulence or recirculation on the high limit switch.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.